If you are building a voice AI infrastructure or voice AI platform, you must need to know about the voice AI pipeline and each module inside that, because latency matters a lot in the voice AI platform. In this video, I will walk you through about each module of the voice AI pipeline, what is their functionality, what is orchestrator layer, and type of the voice AI pipeline itself. Let's get started. Okay, perfect. Let's deep dive into voice AI pipelines. So first of all, what is voice AI pipeline? It's voice being spoken by human, and through it pass through a specific software, third party SDK, or a piece of processing. It gives output to human understandable format. So that's exactly the voice AI pipeline. So in the voice AI pipeline, we will understand the basic fundamental to start beginning. So first of all, it comes as a voice. There is two kind of pipeline. One is voice to voice pipeline, and the second one is voice to text and text to again voice. So that's a little bit older, but more deterministic and have more reasoning power. And the voice to voice is more faster, but have less reasoning as of today because of the nature of the pipeline, right? So I will walk you through the second approach more into detail. Voice to text and text to voice. Basically, for the user, it will be more of a latency between 500 millisecond to 2 second based on LLM they are using. Yeah. So three different steps we can kind of discuss. So as a user, they speak voice. It goes to speech to text. So we have a lot of option on the speech to text. Let's say diagram. It is assembly AI, like that. Then now we have a voice over here. Then it converted into text. Then it goes to LLM pipeline. So text input and text output. And then there is a third part that comes in is now you have a text to speech, and that's where the best one is 11 left so far. Then there is a rhyme, and then there is a lot other as well in place, including deepgram too. So that's and then as a user they hear voice again. So let's say over here we say hello. So this voice, it's in the modulation of voice. Let's say it's of 16 kilohertz, or let's say 8 kilohertz with let's say 44.1 kilohertz of frequency, sample rate, sorry, 8 kilohertz, let's say frequency. Let's say it is with mono channel. So those are like a bit of description or technicalities of the voice. Then this voice being converted into text. What process happen over here in STT? The voice comes in. It detects when the voice started, what user has spoken, and then it converts into text. It is basically in the streaming. Why streaming is required? You cannot wait completely when STT is completed, because the latency matters a lot in this case. I will come back to this latency part at the later stage. So when I spoke hello, let's say it converted into text. So this as an input goes as a 101010 like this in the voice modulation, and then it converted into text, say hello. Now once the hello is there, then it goes to LLM. LLM says, let's say it's an OpenAI 4.1. Input comes hello. Based on the prompt has been given to them. Instruction basically in guardrails. It will answer you. Let's say just example. How can I help you today? Then this text is being generated by LLM. It goes to TTS. What does TTS does? Let's say level less. This text has been fed as an input and it gives you voice. This is not MP3 or WAV file they give. What they give is basically what they give as an output is a streaming output. Why? Because that reduces your latency, but at the compromise of quality. I will deep dive into that quality part as well. So what happens? I said hello. It went through speech to text. Then it went to LLM. LLM took input as a hello. It responded, how can I help you? And then it went to text to speech. And then again there is a voice modulation, voice output that came in, which human can hear. It's a speaker basically, right? So that's the basic pipeline. Now let me go deep dive into that, right? Where is the orchestrator layer, what it does and how it does, right? So let's say this is your orchestrator layer. It is connected with STT. It is connected with LLM. It is connected with TTS. When orchestrator layer, it starts like, let's say, hello, you hear? Orchestrator layer says, okay, perfect, give it to STT. When STT says the end of sentence, it directly feeds into LLM. It takes those LLM out when it started, let's say, time to first open, it completed. It started giving that to TTS, and TTS output it basically give it to wherever it's needed. Let's say it's your telephony provider, or it's on your webhook, or let's say streaming webhook basically. So that's what Orchestrator does. A lot of things. What it does in essence, it has a multi-threaded system. It has all the configuration. It has latency check in place. It knows when one pipeline node is completed, then feed it to second one. What I mean first and second, basically, let's say STT completed, pass it to LLM. LLM started generating output, give it to TTS, and TTS when started generating output, it goes to user as a speaker or let's say as an output. So an orchestra has a lot of state management in place as well. It is the session management as well. It has couple of inbuilt functionality, let's say filler word. What I mean by filler word, let's say while we are waiting for user out, let's say if it called one of the tool, let's say function tool, let's say says, okay, user say, hey, can you check availability? I want to book an appointment. It goes, LLM says to orchestrator, hey, please call one tool. LLM doesn't call tool because it's a specified private API. So LLM doesn't take control. LLM says to orchestrator. Orchestrator calls the tool and tools once being called. So meanwhile, the response being received for the tool or API or function, orchestrator have a functionality where it says, hey, I'm checking for you. So that's called a filler word. Hope you understand that clearly. And then orchestrator has basically all the integration in place. What I mean by integration, let's say who is telco provider, STT, TTS, transport layer. So basically, orchestrator layer makes a pipeline. Also, in the orchestrator layer, it has an observer. What I mean by observers is like once the call is completed, do a sentiment analysis, whether it was successful or no, and evaluation criteria as well. Where in evaluation you might have a length fuse, you might have a length smith. These are all the different, and then you have a then there is different eval libraries too. Yeah, that's all about, in essence, about voice AI pipeline. For the voice to voice, what happens is basically, let me quickly walk through that as well. In the voice to voice comes in, then there is orchestrator layer again. Internally, they handles everything, LLM and those things, and that it gives you very quick as an voice AI. Voice is an output. So input and then output. I'll walk you through in the voice to voice in the second video after this. Let me explain you first of all. So what is voice AI pipeline is basically voice comes as an input and then output is also voice. It has basically three nodes or pipeline points in place. STT, which is speech to text, uses speech, it converts into text, that text goes into LLM, that LLM again gives output as an LLM, as a text, and then basically that text feed into TTS. So the voice comes as an output basically, right? Perfect. So that's the three fundamental. Now what is, so as an input, when you provide voice, it has a specific frequency, it has specific sample rate, it has specific, I would say, a mono channel, or let's say, mono channel, or I would say dual channel as well. And then it goes as an input 1010, STT like deprogram and assembly that converts that text into that voice into text. That text goes into LLM, and then again LLM provides you, after reasoning, it gives you output in the text. That text goes into TTS, right? I mean, that's how basically the system works. Perfect. So this is very clear system in place. Hello words goes in an input, STT, LLM, and TTS, and then it gives you output. And then I've introduced a concept called orchestrator. What orchestrator does is, you give, let's say, hello, it internally handles this whole pipeline. It knows what is the current status is, where the voice is, what is the session, who is user, latency check in place, state management, and then basically whenever it's needed, it calls a filler word as well. So yeah, it handles. Orchestrator basically is a handler of this whole pipeline. Basically, it is the brain behind this all three. Yeah. Perfect. Yeah, that's it. If you do have any question, happy to answer. Perfect. Bye. Thanks for watching this video so far. Hope you get the insight about how Voice AI platform and the pipeline works. If you are building or wants to build a Voice AI platform or Voice AI pipeline, we are more than happy to collaborate with you. I have added my Calendly link in the description. Feel free to contact us. Thank you so much.